So in the non-redundant covers, we are looking for those functional dependencies which are unique for a particular relation or a particular table. So in a relation, there are many attributes, or in a table, there are many attributes. These attributes we represent in terms of columns, and the relation between these columns, these attributes in a relation or in a table is called functional dependency. So when we define any table, and in one table we have many functional dependencies which is defined. So we have to look for those functional dependencies which are redundant or which are duplicate functional dependencies. So we will try to remove those functional dependencies and will make a non-redundant cover of the functional dependency. Now here, if you see this, uh, in this, let's say if we have one functional dependency like x determine y, and we are suspicious that this particular functional dependency is a redundant functional dependency. So what we have to do? So we have to find out the closure of x under all the functional dependency, and we'll remove that functional dependency. We'll consider all the functional dependency except that particular functional dependency which we are going to check. And we find out the x closure. And if this x closure is equal to r, then we can say that this x determined y is redundant. And we'll remove the redundant functional dependency from the functional dependency set f. And we got the non-redundant cover. Getting it? Now let's see this in the form of one example. So this is one example. In this example, we have a relation R or a table R in which we have different attributes A, B, C, D, E, H. So these are my attributes. And these are the set of functional dependencies. We have to find out non-redundant cover. It means we have to remove those functional dependencies which are duplicate, which are redundant among these functional dependencies which exist here. Okay. So here we doesn't have to bother about what are the data inside the table or inside a relation. We doesn't have to bother about it. We have to see the functional dependency, and based on the functional dependencies, we have to find out the non-redundant cover. Non-redundant cover. So let's see this, how we can solve this. So this is the functional dependency that is given. Okay. Now what is our task? Our task is to find out which particular functional dependencies, 1, 2, 3, 4, 5, 6 functional dependencies are there. Which particular functional dependency is a redundant one? Okay. We have to find out and we have to remove it. That's all. Now let's check one by one. So first check A determine BC. So we check for A determine BC whether they are redundant or not. Okay. So we'll write it. Check for A determine BC. Now while checking it, we have to find out A closure. And we have to see that A closure is equal to R or not. If it is R, we'll remove it. If it is not R, we'll see it, what we have to do. Okay. So how we'll find out A closure? We'll find out A closure without considering this functional dependency. So you just assume that this functional dependency doesn't exist right now. We'll find out A closure with rest of the functional dependency. So what is A closure? A closure will be A, right? Now A is determining anything? No, A alone is not determining anything. So we cannot go further. A closure will be A only, and it is not equal to R. If it is not equal to R, it means that this is not a redundant functional dependency. It means this functional dependency should be there in the functional dependency set. Now, let's check for other functional dependency. Now, let's check for CD determine E, the second functional dependency. Okay. Now, while doing it, we have to find out CD closure without using this functional dependency. So what we are assuming? We are assuming that this functional dependency doesn't exist. These are the functional dependency which exist, this one, and rest of the functional dependency which exist. Now we have to find out CD closure. So CD closure, C and D will come in the set. Then we have to look for C is determining anything. C is not determining anything. D is determining anything. Yes, D is determining A, E, H. A, E, H. Okay, what is okay? Now A is determining anything. Yes, A is determining B and C. C already exists. B will come. Now, if you'll see, it is A, B, C, D, E, and H. It is equal to R already. We doesn't have to go for other determinant to find it out what are the different closure of. It is equal to R. It is equal to R. It means that this is redundant. This is redundant. It means that we have to remove it. So what we do here, we assume that this doesn't exist. Means we have to remove it. So we'll find it out that this is redundant. Okay, and this is redundant. So I'll just make it in a different color so that we can understand that this doesn't exist. So this particular functional dependency doesn't exist for us and we are removing it. So this has been removed. Now, what are the functional dependency? Right now we have, this is the functional dependency, this one, this one, this one, this one. So we have, these are the functional dependency, which is right now we have as a non-redundant cover. Now we have to look for, we have seen, we have checked this one, this one. Now we have to check the third one also, right? So we'll go for the third one. Third one is check for E determines C. So how will check E determines C? We have to find out E closure. And without using this functional dependency, So we assume that this functional dependency doesn't exist right now. Now rest of the functional dependency means A determine BC, D determine AEH, ABH determine BD, and DH determine BC. These exist. Yeah. Now we have to find out E closure. E closure will be E will come. Now E is determining anything. If you'll see here, E doesn't determine anything. It means that it is not equal to R. It means that we need this functional dependency. This functional dependency is not a duplicate functional dependency. Right? So we'll just, yeah. So we have checked for the third one and find out that we require this functional dependency. Now let's go for the next one, which is the fourth one. Fourth is your check for D determine A, E, and H. Do we require this? So we have to find out D closure without using this function dependency. So we assume that this function dependency is not here for our time being, and we find out D closure. So D closure will be D. D is determining anything. You will see here No other functional dependency determine means it is determined part is D. So we cannot go further, and it is not equal to R. It is not equal to R. It means that this functional dependency is not a duplicate functional dependency or not a redundant functional dependency. It means that we require this functional dependency. Now let's check for the fifth one, which is A, B, H determines B, D. Do we require this? Okay. So for that, we have to find out A, B, H closure without using this functional dependency, right? So we assume that this functional dependency doesn't exist for a meanwhile, for a time being. Okay? Let's find out A, B closure, A, B, H closure. So it will be A, B, and H. Let's go for A. A is determining anything? Yes, A is determining B, C. So B is already there, C will. Then B alone is determining anything? No. H alone is determining anything? No. What about any combination? No. So we are not getting D here, right? A, B, C, D, and E. D and E we are not getting it, right? So it is not equal to R. If it is not equal to R means we require this particular functional dependency. Is it correct? So A, B, and H. A determine B, C. B is already there, C will come. Then B is not determining anything. H is not determining anything, or combination of all these are not determining anything else. Yeah, so it is correct. Right now, we'll just, so we required this functional dependency because it is not equal to R. Now let's go for the last one, the sixth one. It says that check for DH determine BC. Let's do it. So we have to find out DH closure. It will be equal to without using this again. So we are just removing it for a time being. Yeah, so we have to find out DH closure. So D and H will come. Now D is determining anything? No. H, okay, yeah, D is determining. D is determining AH. A, E will come, H is already there. Now H is determining anything? No. A is determining anything? Yes. A is determining B and C. So B will come and C will come. So I think all are here. A, B, C, D, E, H. It is equal to R. It is equal to R means this is a redundant one. A redundant one means we have to remove it. Okay, I'll just change the. Okay. So this particular function dependency we find out is a redundant one. Yes, is a redundant one. So we'll just vanish this particular function dependency. Now, what is a cover? So we have checked all the functional dependencies and we find out that the two functional dependency, which one? The second one and the sixth one are redundant. So what are the leftover functional dependency? We'll write down here. A determine B, C. E determine C. D determine A, E, H. A, B, H determines B, D. Yeah, so these are the non-redundant cover. And this is my answer. A determine BC, E determine C, D determine AEH, and ABH determine BD are the non-redundant cover. So I think you understood this particular concept. So how we'll find out the non-redundant cover? by looking for all the functional dependencies, whether they are duplicate or not. If they are, how we'll find out whether they are duplicate? This is the procedure to find out. We have to find out the closure of the determined part. If it is equal to R without using that functional dependency, then we'll say that this particular functional dependency is a duplicate and we do not require it. So this is how we go for the non-redundant cover.